request you uh, have a paper and pen with you. Okay. So we are supposed to do the problems in the today's class. Okay. You also should do the simultaneously. You should solve the problem with me. Okay. So what my request is, please have a paper and pen with you. We'll do the problems. Okay, I will give you the algorithm and all. So what is the procedure and all? Not, it's not like an algorithm. It's like a procedure. Okay, how to do the operation. Then we'll do the division operation. Okay. So if you remember uh, how the division is done, sorry, how the normal division will take in place, right? So what is the normal procedure? We will be having a dividend, we will be having a divisor, right? So now we are going to divide, right? So dividend will be divided by the divisor, isn't it? Now let us see how the division will be taken place. Okay, so let me show you first the slide. I'll just share it. Okay, yeah, uh, just a minute. Okay, you're able to see. Yes, you're getting the screen now. Yes or no? Yeah. Okay. See, we are supposed to do the normal division. Okay. See, first let me write one small normal method. So how we will do normally. So suppose I will say you, suppose you take 8. Okay. So divide this 8 by 2. Okay. I'll ask you divide 8 by 2. What we will do? We'll take it as, so this is 8 as dividend. So 2 I'll take it as divisor, isn't it? So we'll be getting 2 fours. So whatever is remained, so that is not said to be a reminder. This is said to be a quotient, right? So we will be having a normal procedure of division. It's very simple and it is easy also. So similarly, here we are supposed to do the operation of division not with respect to your decimal values. We are supposed to take the binary values. Okay, something like this. Okay, so what we should do? Suppose 2 means 1 0, 8 means 1 0 0 0. Okay, now we are supposed to do the division operation. Okay, so for this purpose we have two methods. One is restoring division and one is non-restoring division. Okay, two methods are there. First let me tell you the first division method, that is restoring. Okay, please note down this. Okay, I'm writing on this. So division. Okay, non-restoring. Okay, so the second method is non-restoring. See, so div means division. Okay, so there is two methods are there. So the using the two methods we are going to do the division operation. Let me show you the here the manual method. So I've already told you. We have to take the dividend. We have to take the divisor. Then we have to do the operation of division. Okay, so this is normal method. How to do the normal division method, manual division method. So manual division methods actually we are not required, because in the arithmetic operation we are not going to use the manual division method. We have to use the the methods known as restoring division and non-restoring division method. So there, HOD member. Okay, so this is the see, we are going to use the a circuit arrangement. So I already told you we have a circuits will be there. Okay, we have to use the registers. Okay, to do the operation inside the ALU. Okay, for that purpose what we are provided is, here is we have a circuit arrangement. We have, so if I tell you right now this circuit arrangement, you are not able to understand anything. Okay, so except these two data, what is that? Dividend is here, some divisor is here. Other than these two data, you are not able to understand anything. Okay, for that purpose, what I will do, we will solve the problem. Okay, now problem. one or two problem, then we'll come back to the circuit arrangement. Then it will be very easy for you to understand what is that circuit all deals about. Okay. I hope you are clear. Okay. So let me take the problem directly. Let circuit arrangement. Okay. So then, yeah, then you are able to understand very easily. So take this first method is restoring division. Okay. As I said you, we are going to discuss the first method of division, that is restoring division. What is restoring division? It's very simple. We are supposed to do only 4 steps. Proper, procedure you have to follow. What is that proper procedure? What we should do? See here, we have to use some two registers. See, A is one register and Q is one more register. Okay, so you can call A as something known as accumulator or anything you want. Okay, so this is one of the register A, and it is one of the Q register. Okay, so what I will do initially, what I will do inside this particular registers, what we are supposed to keep. Okay, so probably we have so the important thing we have to keep it in your mind is A will be a register. Okay, A will be a register. Initially, the data will be 000, something like this. Okay, so then we have a Q register. It will be available. Okay, that going to fill inside this will be dividend. Your dividend. Okay, so which data you want to divide? That is your dividend. Okay, dividend you have to keep it inside the Q register. Okay, and you have a divisor M will be there, so that we will be used due to the operation. Okay, division operation, so that will be available in one of the separate register, so that is said to be a divisor M. Okay, so I'll call it as M as my divisor. M is nothing but divisor. Okay, M is a register which holds divisor. Okay, so let us take this simple example program. Just see here. Okay, suppose if you see this one particular example, see here, I'm going to divide 8. 8 is what? 100. Okay, 8 is 1000. So my question to you is divide 8 by 3. This is what my question. I'll ask you to divide 8 by 3. So then you have to take your 8 will be divided by 3. Okay, that is nothing but, so a simple method. That is nothing but 0. That is nothing but 8. You have to divide it by 3. Okay, so normally it's a very simple procedure. What we should do? So take, so you have to take first this. See, since 10 is 2, normal method. Okay, I don't want to do this because it's a normal method. So 10 is 2 and 11 is 3. That is why what I'm supposed to extra one more bit, so 3 bits. So whenever I'll take 3 bits, what is the value now? 100, 4. Okay, now 3 you are going to divide, divide the 4 by 3. That is nothing but 1s are. 3 ones are 3, so I'm writing here 1, 1. So now normal method, so 0, 0 plus 1 is 1. Okay, see here, suppose whenever we have written data like this, 10011, we have to subtract, right? Now subtract it. So for that purpose, what we could do, 0 by 0, you can't subtract your 1 value. So you should take the extra carry. That's nothing but 2. So out of 2, 1 here 2. So out of 2, you are going to subtract 1. So 2 minus 1 is 1. So 1. So here obviously 1 is remain. So 1 minus 1 is 0. So this is what? 1, 0. You are left with your remainder 1, 0. This is the manual method. Actually, we don't require manual method right now. Okay, so not require this. Let me go to the problem directly because we are going to explain you as per the syllabus restore and non-restore. Okay, so directly I'll go to restoring method, which is actually required. Okay, go to restoring. Later I will come back to normal method and all. Okay, we'll take the initially will be 0. See here 0 0 0 0 completely. So that's what your register A initially 0 0 0 0. Okay, then you have a Q. What is Q? Q is nothing but you have a data that is dividend. Dividend is what? 8. 8 you want to divide, so that's why I'll keep it here. Okay, next what I should do, I'll take my one of my register, one more register M. Inside that M, I'm going to keep the data divisor. What's the divisor? 3 is the divisor. Okay, that is what? 0 0 0 1 1. Okay, so initially you have a register 0. Q will be your dividend, and your M is nothing but what? Divisor. Okay, all these three you have to keep it like this. Hope you are clear. Okay, now what you should do, the very important, the beginning concept is you have to see to it so that you are able to continue further. So what's the meaning of continuation? Just see this. You have to shift. First thing is shift. First procedure they have given in the list, that is shift A and Q left one binary position. First thing you have to do is shift that A and Q towards left side by one binary position. Hope that is the first step you have to do. Okay, so what I will do, I'll go here, I'll shift it. That's what I'm doing now. So just shift it. So this is your A. I told you this is your A. This is complete data is your A, and this is your Q. You have to shift left. Okay, shift left by one bit. They have given in the procedure. So I'll shift it. Okay, on shifting, what will happen? So this 0 will be shifted towards left side. Okay, now, so this will be blank. Keep it empty. Don't write anything here. This is empty. Okay, so this 0 will come here. This 0 will come here. This 0 will come here. This 1 will be shifted. See here, this 1 will be shifted. Next, this 0 will be here. 0, 0, 0, 0. Okay, first you have to shift. Have you understood this first procedure, first step? Whenever I'll give the dividend and divisor, first thing is A will be 0 initially, M will be your divisor, Q will be your dividend. Okay, after that, first thing is you have to shift A and Q. Don't touch M. Okay, don't take M in any way. Okay, till here, are you clear? First step, are you clear? Are you clear with the first step? Why no reply? Hello, you're there. Can you explain again? Okay. Please, some more people. Everyone, actually 63 are there here. Everyone should answer to my question. Are you clear? First step, are you clear? Okay, only two students has given the reply. Again, ma'am. Yeah. Very good. Yeah, very good. You should, yeah, you should ask me like that. Then what I will do, I'll take one more number and I will show you. Yeah, please. Everyone, if you have not understood, please tell me no, ma'am. Nothing to worry. I'll take one more number and I'll explain first step. Then we'll continue with this problem. Fast, fast. If it is understood means everyone will type it as yes. You are not understood. That's why you are not replied. Okay. Yeah, it's okay. Let it be. So I'll take one more number. Then I'll tell you. I'll write. That's better. I'll erase all. Okay. Okay. Let me take one number. This number I'll come back again. But right now I'll take one more number. Suppose I will give you. You have to divide 10. I'll take not 10, I'll take some 9, I'll take, that's better. 9 divided by 3. Okay, so what you should do is, please understand here, everyone, what you should do is, see here, you have a registers. Okay, I told you have to use 3 registers. One is A, one is Q, one is M. Okay, so in the register A, you have to keep 0, 0, 0. Okay, that is your 0, 0, 0. So shall I write it here? 0, 0, 0. Ma'am, how many zeros you have to write, ma'am? It is very, very important question. What you should do, just to see, just your dividend. What's your dividend? So what's the maximum bits you are required for a dividend? For 9, you can represent your dividend as 1001. Are you agree? 4 bits. Are you agree? So write it here. In the Q, you have to write your dividend, right? 1001. Now, your divisor, no. What your divisor you will take, what your you will take, no. Your register A or your divisor M. For that, you have to take the number of bits of your dividend plus 1, additional plus 1 bit you have to take. Okay. So, if 4 bits is your divisor, sorry, your dividend, then what you should do, take one more extra bit. That means 5 bits. 5 bits of 0, you have to keep it inside the register A. Okay, are you clear? This is A, this is Q. Now M, I'll write the M. M means what? Divisor. Who is the divisor? 3 is the divisor. What is 3? How can you write 3? Can I write it as 1, 1. I'll write 0, 0, 0, 0, 1. That is also fine. You can directly write just 1, 1. 1, 1 means directly, if you write 1, 1, by default it is something like 0, 0, 0, 0, 0, 0, 1, 1. Are you agree? Both are same, isn't it? So you can write like this. Are you clear? So totally your A also 5 bits. Your M means what? Divisor will also 5 bits. This is your A, Q and M. After this, the first step is what you should do as per the given algorithm or procedure. Shift A and Q. Don't go to your M. Shift A and Q towards left side by 1 bit. So what I should shift, right? So whenever I'll shift, what will happen? See this space, no, your A will be shifting towards left side. So this anyway, this bit, last bit will be empty. I don't know what to fill. So keep it empty. Okay. Then take this one towards left side. 1. So this 0, 0. See, I'm writing this one. Don't check what ma'am is doing like that. Okay. See, this 0 are at here. This one shift. This one. See, I'm taking this one. 1. So this 0 will be this side. So this is 0. This 0 I'm shifting. See this 0. 0. Then this 0. All are zeros only. So I'm shifting towards left side. This is what actually first step. I think this is one space is empty. 1, 0, 0, 1, 0, 0, 0, 0. Are you clear at least now? Your first procedure? Eega clear aita? Now you clear what is A, what is Q, what is M, and what is the first step? This is first step actually. Now please type me yes or no at least now. Don't give only 4 people, 5 people and all. Everybody should give me the message. If you're not understood, tell me no, ma'am. I'll explain. Only 5 responses. Everybody should message. Yes. You have understood A, you have understood M, you have understood Q, right? Yeah. How many zeros you have to take in? A and Q A and M, you have understood. Okay. So what is your dividend? Plus 1 extra bit you have to take. That's very, very important. Okay. So now come to the problem here itself. So this will continue later, this problem. I'll continue with my existing problem. See, so I've taken the data Q. What is your Q? Q is your dividend. That is what? 8 is your dividend. Okay. Divided by 3. So 3 is your divisor. That's what I have done here. So I've kept your dividend 1000, okay, in the register Q. Then A will be 0000. Okay, initially it will be 0. How many zeros? 1 bit extra to your dividend. Okay, your 4 bits is here, so 1 bit extra. So 10000. Okay, 5 bits of zeros. Next divisor. Who is divisor? 3 is the divisor. Okay, so 3 will be 1 1. I can represent using 1 1. But even you have to take it as a 5 bits position. That is why 0 0 0 1 1. After this, first step is how to shift your data towards left side. Okay, shift towards left side by 1 bit. So that is 0 0 0 1 0 0 0. Okay, if you want, you just see. Okay, this 0 will be shifted towards left side. This is shifted here. This is shifted here. This 1 is shifted here. This 0, see this 0 I've shifted here. This 0 is shifted here. This 0 shifted here. This 0 shifted here. Okay, shifted continuously towards left side. This is blank now. This is blank. Okay, now come to the second step, which is very, very important. Let me see. See here, in the second step, subtract, please see here. Subtract M from A. Subtract M from A and place the answer back to A. That's your next thing. You have to do the second step. What's the second step? Subtract M from A. Okay, and place the answer back to A. Okay, so that is your second step. Okay, so you have to, first thing is you have to subtract M from A. Okay, so go to your problem. See here, I'm subtracting. So this is your data. This is your A now. Right now, this is your A. From this A, you have to subtract M. What's your M? M is 0, 0, 0, 1, 1. Yes or no? Tell me what is m? Right now, what is m? Tell me. Tell me what is m? Yeah, that is your divisor, right? So you have to subtract it from a. So this is your a. So now this is your a. From this a, you have to subtract your value. Which value? Divisor value. Okay, how to subtract? Normally we know the simple procedure. What's the simple procedure? How to subtract? How to subtract actually? Suppose I will give you, this is the a. A means 0, 0, 0, 0, 1, right? This is your a. Okay, subtract your a, subtract your divisor. What's your divisor? 0, 0, 0, 1, 1 from a. So this is your m, this is your a. Subtract m from a means what you will do? It's like you're minusing. Are you agree? You're minusing, right? Minus, right? So what's the meaning of that? So minus means take the 2's complement. Very simple. So what is the 2's complement of this? Isn't it? Minus means what? 2's complement of that. Isn't it? Suppose I will say here 2 minus 4 means what you will do? 2 is nothing but 1 0. 4 is nothing but 1 0 0. But can you write 1 0 0? No, we have to take the 2's complement of that number. Isn't it? So like that, I will take the 2's complement of this. Okay, divisor 2's complement. What is divisor 2's complement? So 2's complement is 1 1 1 0 0 plus 1. 1's complement plus 1 will give you 2's complement, isn't it? Oh, that is what? 0 plus 1 is 1, 0, 1, 1, 1. So what's your answer? 1, 1, 1, 0, 1 is the 2's complement value. What is your minus m? Minus m means this is the value. Isn't it? Are you agree? So that is what I'm subtracting means I'm taking the 2's complement of that. Okay. So I'll just erase all this. You're able to understand now. Okay. Now subtract. Subtract your register A. Okay. So with the value m. What is your m? M is 0, 0, 0, 0, 0, 1, 1. How to subtract means it's a negative value. Negative value means 2's complement. 2's complement means 1, 1, 1, 1. Okay, that's why I've written here 1 1 1 0 1. If you understood, if you are able to see this, you are able to understand. I think 1 1 1 0 1. Okay. So subtract. So I've taken the I've negated the value. So I'm just going to add it now. So 1 plus 1 is 0. Carry 1. So carry 1. So I'm keeping here 1. So 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 1 is 1. So this is what actually the first procedure. Have you understood subtraction? Have you understood this? Normal procedure, right? So normally binary subtraction means what? What we should do? So this is what your data. So your data is 0, 0, 0, 1 is your A value. Now subtract your M. M means what? 0, 0, 0, 1, 1. So subtract. Okay, what is subtraction? So suppose as I give an example, 2 minus 4 means 0, 1, 0. 4 means what? Actually 1, 0, 0. But shall I write it as 1, 0, 0? No. I have to take the 2's complement of it, isn't it? So what's the 2's complement of this? How it becomes minus 4? How 4 becomes minus 4? By making 2's complement, isn't it? So your 4 is nothing but 1, 0, 0. Okay, next take the 2's complement of the complement. What is that? 0, 1, 1. For that you have to add 1 so that it becomes 1 plus 1 0, carry 1, 1 plus 1 0, carry 1. Okay, so this is what your 2's complement, right? So this is the 2's complement value. That is nothing but minus 4 is equal to, again the same value is getting here, 1 0 0 only getting, 1 0 0 is a minus 4. Okay, now we have to 0 plus 0 is 0, 1 plus 0 is 0, 0 plus 1 is 1. Then you have to add. So this is what your answer. What is your answer? Something like it could be minus 2. I hope everybody is understood, isn't it? Okay, so like that, what I have done, I've subtracted this m. Now subtract means takes 2's complement. Okay, that's my first step. Okay, I've done till here. So as soon as you have subtracted, as soon as your subtraction done, go to the third step. What's the third step? See here, the third step is C. Just see this third line. Everyone, please read out it. If the sign of A is 1, please understand this. If the sign of A is 1, set Q naught to 0 and add M back to A or restore A. Otherwise, set Q naught to 1. Have you understood this line? If sign of A is 1, sign bit of A is 1, okay, if that is the case, then set Q naught to 0. Okay, then add M back to A, restore it. Otherwise, set Q naught to 1. Okay, yeah, let me tell you. What's the next thing is, just see your Q naught. What's your Q naught actually? So this is your Q naught position, right? So this is your space. You have left now, this data I have left. We have to fill this data. So I have to fill the data. How to fill the data? Just see here. So just see to this. You have a data here, right? So this last bit, you have to check it out. So what's the value of this bit? Your A. A is, what's the value of A? So your A value is right now here. The leftmost position will be 1 it is. If this is 1 means, then your Q naught will be set to 0. See here, 0. So here you have given a space, no? After shifting, you have given a space here. This space will be filled by 0. See here, I filled it by 0. Hope you are clear. Okay. So fill it 0. And after that, others I'll fill it here only. So 0 I'll fill it here. This is 0. So this is normally existing 0, 0, 0, right? So after this, what I should do? Add divisor M back. Okay, add divisor. What's your divisor? 3 is your divisor. So add here. 1, 1. Add it. So what value you will get? 0 plus 1 is 1. 1 plus 1 is 2. So 0. Next, see, 0 plus 1, 1 plus 1 is 0. Carry 1. So 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. Neglect this one. Okay. So that is what. If this bit, if the last bit will be 1 means, you have to set your Q naught as 0. Hope you are clear. Suppose if this is not 1, if this is 0 means you have to set your Q naught as 1. Ulta. If this is 0, rightmost bit of your A is 0, 1 means reset your Q naught to 1. If that is 1 means reset it to 0. Ulta. Okay. So restore it back. Okay, hope you are clear. So after restoring, you are getting your data. So what data you are getting? You are getting this data as 0, 0, 0, 0, 1. Okay. So I'm getting this value. This completes your first cycle. This completes your first cycle. Okay, then this step should be follow again one more time. What's the next step? Again, see this algorithm. So next step is what? Repeat these steps n number of times. Repeat it. N number of times means how many number of times? How many bits of dividend you have? That many that many times you have to repeat it. So what's your dividend? How many bits? 4 bits. So you have to do it for 4 times. Okay. Now I completed first one time. Now you go to one more time. Okay. What's your one more time? One more time is again I will go to the next shift operation. What's your shift? You have to shift your A and your Q naught. Q and A you have to shift it. So this is what? So I'm right now here. Till here I'm available. This first cycle. Now shift it. On shifting towards left side, you have to shift everything. This is 0, 0, 0. This 0 will becomes here. This 1 will be shifted towards left side. Okay, shift it. After shift, next thing is you have to do the subtraction. Common procedure. So subtract it. Okay. On subtraction, I told no. So your divisor will be what? Divisor will be what actually? 0, 0, 1, 1. So take the 2's complement of it. 2's complement of it what? I've already written here. See 1, 1, 1, 0, 1. The same thing. 1, 1, 1, 0, 1. Okay. Then you will get the value. So add these two. Shifted value plus subtracted value. You just add. You will get the value. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 1 is 1. Okay. Now you are getting this value. The rightmost the last bit of your register A will be what? Okay, this is 1. If this is 1, what's your Q naught? See, Q naught value will be changed to 0. Your Q naught value will be filled by 0. It was empty, no? After shifting, this space is empty. So there I am going to fill it as 0. Okay. After you're keeping the value of Q as 0, what you should do? You are supposed to make the restoring. What's the restoring? Add your divisor back. Okay, restore it by adding 3 to the data available in the register A. Now add it. 1 plus 1 is 0. Carry 1. 1 plus 1 plus 1 is 3. 3 means 1. Here carry 1. 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. So 1 plus 1 is 0. Just leave it. Leave this extra bit. Okay. So this completes my second cycle. Second cycle. Next third cycle, again same thing, shift it, subtract it, check your the last bit of your A. Okay, so you have a data 0 means you have to change the you have to keep the value of q naught as 1. If the value is 1, keep the value of q naught as 0. That's all. Okay, again shift it towards left side. So I've shifted towards left side. Then subtract it. Yes, I've subtracted. Then on subtraction you're getting this value. Then check this bit. Okay, so you have a last bit. What is the last bit value? 0. If this is 0, what you should do? You have to keep the value of your q naught. Okay, this is empty, no? This data, this is empty. Okay, as soon as you have shifted towards left side, that bit q naught bit will be 0. Empty it is. You don't have any bit. Okay, now you have to write it as 1 here. Okay, edit as 1. Then you are getting the okay, data till here. So after that, same procedure. See, subtract, set q naught and restore. You can ask me one question. Just see here. Just last point which I want to make it clear. What is that? See, whenever you have 1 in the last position of your register A, you are going to restore by 0. See here? 0. So sorry, you are going to keep the value of q naught as 0. And one more thing is you are restoring the value 1 1 1. That means you are restoring your divisor, isn't it? See here also 1 q naught value will be set to 0, and you're restoring means you're adding your divisor to the existing value. Okay, but see here, if you have 0 here, you're restoring, you are writing your q naught as 1, but you're not restoring your 1 1. You're not restoring your divisor. You're not restoring. That you should remember. If it is 1 means you have to restore. If this is 0 means don't restore. Okay, so like this you have to do the 4 number of times. After doing this 4 times, you are going to get the data here. What's your data? So this data, the data inside the register A will be your reminder. What's your reminder? 00010. That means what? 2 is the reminder. 2 is the reminder. And what's the quotient? So quotient is what? 2. 2 is the quotient. Okay, so here also same examples here. You're dividing 3 by 8 means what? 3 2s are 6, right? So what's your answer? So 2 is your reminder, 2 is your quotient. So 2 is your reminder, 2 is your quotient. Are you clear with this? Are you clear? I will do it one more problem. That means I'll take one empty sheet and I will do it. Okay, simultaneously you also should do. But have you understood this? Yes or no? Only one student? Okay, take a paper. Yeah, take the paper and pen. We'll take simple only, okay? What we will do? We'll divide it 9 by 2. Shall we take 9 by 2? Okay? Okay. I'll also do it simultaneously. You also do it, okay? Are you agree? Yes. Shall we do? I'll take one empty blank page. Everybody ready? Yes? Please take a sheet of paper. Yeah, I'm going to use this. First, hope everyone is having the... Okay. So my C problem is 9 divided by 2. So 9 divided by 2 means what you will get? 4 is your quotient and 1 will be remainder, isn't it? Yes or no? Okay, shall we do it now? Everyone ready now? Yes? Yeah. Okay, so we'll go to the, we will take C3 registers. We'll take, first is A. A will be what? Can you tell me what is A value? A will be what? Can you tell me? What's the A value initially? Yeah, very good. 0 0 0 0. See, please understand here, your dividend will be 1 0 0 0. 1. 9 means 1 0 0 1. Okay, now, so 4 bits. This is 4 bits means your A value and your M value will be 5 bits. Okay, hope you are clear. Okay, now I'm writing here initially, same steps I'll write it here. So initially I'm going to take A. What's your A? 0, 0, 0, 0, 0. Why this is 5 zeros? I already told you. Okay, this is your A. Then go to your Q. What is Q? Q is 2. 2 is not, sorry, Q is your dividend. 1, 0, 0, 1. Okay, so I've done. Next, what is your M value? M value is what? Can you type for me? What is M value? What is M? What is M? Huh? What is M? Exactly. Very good. 0, 0, 0, 1, 0. This should be again 5 bits. Okay now. Okay. See, I want actually whenever subtract will come, so this M value will become 2 becomes minus 2. So write it somewhere in your book, your minus 2 value also. Okay, write the 2's complement of 2 and keep it with you. We want whenever we are going to subtract, no, at that time we required. Okay, so right now I am not required anyway. I'll do it now. So what's the first procedure? First thing is what? Shift, isn't it? First is shift always. So shift it here. So I'm writing shift here. Shift what? Shift A and Q. Don't touch divisor. Okay, so what is A and Q? So this is A, this is Q. Okay, shift by 1 bit towards left side. Okay, so I'm shifting now. See, shifting this. So 1 will be shifted towards left side. So this position will be empty. I'll keep it as empty space. Okay, so 1, 0, 0. This one shifting towards left side. So 1 and A will be anything, all or every data will be 0. So 0, 0, 0, 0. Okay, correct? Same. Your answer, my answer, both are same. Same, right? Yes. So type madrappa yes anta, so that I can understand you people are there with me. Okay. Then we take the next ಏನು ಗೊತ್ತಾ ಹೇಳ್ತೀರಾ? Can you tell me what is next? Can you tell me what is next? Subtract. What you have to subtract? You have to subtract your divisor from this A. That's your actually procedure. Okay, subtract. What subtract? Subtract means what? So divisor will be 2. So this is minus 2. Subtract means minus 2. Isn't it? Okay, something like this. Okay. So I've given you to subtract 2. Subtract 2 means take it minus 2. So minus 2 means 2's complement of your 2 value. What's your 2? 0, 0, 0, 1, 0. So 2's complement of it means 1's complement of it plus. Okay, sorry. I was myself wrong here. Yeah, this is 1, 1, 1. Okay. Yeah, sorry. 1, 0, 0, 0, 1, 0. This is my 2, isn't it? So 2's complement is 1's complement of it. That means 1, 1, 1, 0, 1 plus 1. So what we'll get? 0, carry 1, 1, 1, 1, 1. This is what my 2's complement value. Everybody correct? Correct? If I'm wrong, please tell me, okay? 1, 0. That means minus 2. I've written minus 2. Everyone correct? Everyone written? Yes? Yes or no? Yes, correct, right? So I'll just add this. So 1 plus 0 is 1. 0 plus 1 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 is 1. Okay. So if you want, I'll write it here one more time. So this I'll write it as, this cube is as it is. 1. This is empty. Empty means, okay. Now see, if you write, so this bits means you can consider, this is the rightmost bit actually. This is the leftmost bit. Left side, no? So this is leftmost, this is rightmost actually. Okay. So this is your rightmost, leftmost. That means last bit. Okay. Like this. Here, come to this. Okay. This bit you have to check it out. If this is 1, what is your Q naught? Q naught means your initial. This is Q naught means 0, the bit position, rightmost position. Okay. So what is this value I should fill? What is the value I should fill here? If this is 1, what is the value of this? 0. Very good. That is why I will write here set Q naught. Q naught means your initial bit, the rightmost bit, you have to fill it. Okay. What is your Q naught now? I'll change it to 1 here. So this is 1, 0. This is, if this is 1, your rightmost bit of, leftmost bit of your A will be 1 means your Q naught will be 0. That's all. 0, 1, 0, 0. And I told you already, if this is 1, what you should do? You have to restore also. Hope you are clear. If this is 1, set Q naught to 0 and restore it. Otherwise, don't restore. Okay. Now restore. What's your restoring? Restore your divisor. Please write it here. Restore your divisor. That is your given instruction. What's the restore? Restore means add it. Add your 2 again. What's your 2? 0, 0, 0, 1, 0. That means you're restoring your divisor. Restore it. That means add it once again. So 1 plus 0 is 1. 1 plus 1 is 0. Carry 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 1. So I don't want that extra bit. Okay. So I've restored. So this is what my data now. 1, 0. Okay. So this is complete procedure until here. We'll call it as ಏನಪ್ಪಾ cycle 1. First cycle. Now everybody understood? Everybody understood? Yes. Okay. So see this bit, the leftmost bit. If this is 1 means your value of Q naught will be 0. Then you have to restore your divisor. Otherwise, if this is 0 means your Q naught will be 1 and don't restore. This point you have to remember. Okay. Now what's our next procedure? Same thing. Shift. Second cycle I'm doing right now. Okay. Second cycle. Hope you are able to understand what I'm writing here. Okay. So shift here. So first, next is shift. Shift means shift means what? This is empty. I'll keep this as empty. 0, 1, 0, 0, 1, 0, 0, 0. Okay. After shifting, next thing is subtract. Same thing. See, same thing I'm repeating here. After shift, subtract. Can you give me the answer? What is the register A value? Can you somebody give me the answer? Subtract. Subtract means what? What's my value I should subtract now? Can you somebody give me the answer? Give me the value. What's your subtracting value now? I'm going to subtract now from register A. What is that subtract value? 0, 0, 0, 1, 0. Hemant was given. Yeah. Why this is 1, 1, 1, 0? Because I'm subtracting m. M is 2. But subtraction means take it negative. Okay. That means 2's complement of your 2. That is nothing but 1, 1, 1, 1, 1, 1, 0. Subtract it. 0, 1 plus 1, 0. Carry 1. So 0, 0, 0. All are zeros. Okay. All are zeros. Are you agree? Is this correct? Am I correct? Sari delappa. Okay. So now what you should do? Check the, see, next set Q naught. Next procedure is set Q naught. Can you tell me what is your Q naught value? Somebody tell me what is Q naught value? See, this is 0. Yeah, Q naught will be 1. Everybody understood. Then shall I restore it? Shall I restore? Since it is 0, shall I restore? No, no need to restore. Very good. No need to restore. Just change, just set your Q naught value will be 1. That's all. This one, no, I've filled it by, see this empty space I've filled by 1. That's all. Set Q naught. Yes, I've set it. See here? I've set Q naught. Yes. But don't restore. Please don't restore. Okay. So this is what your cycle 2. Second cycle. Then go to third cycle. A step. If it is 0 means you have no need to restore. No need to restore the value. divisor value, just put the Q naught value by 1. That's all. Stop it. Then go to next step. Shift. Same procedure appa. Follow madi. Okay. Yeah. Shift now. This is empty. So I'm just shifting. So this is, I'll keep it as empty. 1, 0, 1, 0, 0, 0, 0, 1. Okay, now after shift, subtract. So subtract. I already asked you the question. What is your subtract? 2 will become minus 2. That means 1, 1, 1, 1, 0. Okay. So just add it. 0 plus 0 is 0. 0 plus 1 is 1. 1, 1, 1. Yes. Now you got 1 year. See, not 0, 1 year. Can you tell me what is your Q naught? First, Q naught enappa? Q naught. 1, 0, 1. Zero. Right? 0 will be the value. Very good. Shall I restore or not? No need to restore. Shall I restore or I'll restore? If it is 1, shall I restore or no? Yeah, we have to restore. Divisor value you have to restore. Yeah, divisor value is 2. So I'll restore it. 1, 1, 0. See, by default all are 0, okay? I have not written here. By default everything is 0 here. 0, 0, 0, 0, 0, 0, 0, 1, 0. Okay? By default. So 0 plus 0 is 0. Restore means I have to add it actually. So I'll write it here. After set Q naught, restore. Very, very important. Restore. 0 plus 0 is 1 plus 1 is 0. Carry 1. 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 So that carry you just neglect it. Okay. So here till here whatever the value you will be having with you is said to be third cycle. After completion of third cycle. Okay. So next to last cycle. Fourth cycle, right? Because your dividend will be 4-bit. So fourth cycle. Should we go to fourth cycle? Yes. Okay. Fourth cycle. What is the fourth cycle? First step is what? Type for me. What is the first step now? First step enappa? First. Exactly. Shift. Okay. Shift towards left side by 1 bit. Okay. So I'll shift it now. Okay. This is, I'll keep it, so this I'll keep it as empty because I have to shift it. So this 0 will come towards left side. 1, 0, 1, 0, 0, 0, 0. Okay. So what I've done shift. After shift, can you type for me? Right, exactly. This is subtract. Subtract. So I'll take the subtract. Subtract means again make 2 as minus 2. Anyway, it's already there. 1, 1, 1, 1, 0. Okay. If you want to write it one more time, this Q also you can write it one more time, but not necessary. That's why I have not written one more time. Okay. Yeah, now you are able to see. Yes. Yeah. Okay. Okay. Now subtract 1, 1, 1, 0. I'll subtract it. So 1, 1, 1, 1, 1. Okay. All bits are 1. Just see to it. All bits are 1, 1, 1. So now set Q naught. What's Q naught? Can you tell me? Yeah, it's 0 because the last bit or the most bit will be 1 year. So this is 1 means your Q naught will be changed to, your Q naught will be filled, not changed. It has to be set by 0. See here, this empty space I filled by 0 now. Okay, now fine. Since this is 1, shall I restore or not? Restore divisor or not? Exactly. I have to restore it. What's my restoring value? Will be 102. Now also I'm telling you, you can write 00010. Okay now. Right now 0 anyway I'm not required, so I have written only 10. 1 and 0. That means 2. So now 1 plus 0 is 1. I've written 1 here. 1 plus 1 is 2. That means 0. Carry 1. 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. So that is not required here. Neglect it. Okay. So overflow bit, whatever you will get, just neglect it. Okay. So I got this data 0, 1, 0, 0. So this is what my data I got after restore. Okay. So this completes my cycle, fourth cycle. Shall I continue? One more cycle. Shall I continue? Shall I continue or I'll stop it here only? Shall I continue or I'll stop it here only? After fourth cycle, I have to stop, right? We have to stop for a fourth cycle. That means only 4 bits are there in the dividend. So see, 9 is nothing but 4 bits. So since the queue is having only 4 bits, I have to stop the fourth cycle. Okay, after your fourth cycle completed, take down the readings. What's the readings? See here, the register A, whatever the data it is having, that will be reminder. So what's your reminder? Can you tell me? What's a reminder? So register A is having reminder and register Q will give you the quotient. Okay. So now what is the answer? Reminder will be 1. Isn't it? This is my reminder. Hope you are see this reminder. And this is the register Q is having quotient value. Okay. So this is quotient. So what is the reminder? A reminder will be 1. Quotient will be 4. Okay, corresponding decimal value I'm writing, isn't it? So if you divide your value 9 by 2 means what you will get? 2 4s are 8. So remainder is 1 and quotient will be 4. Am I got the answer? Yes? Everyone is understood? Everyone is understood now? Yes or no? Yes, very good. Yeah. See, in the final exam, even in the final exam also, you can expect one question from the divisor. Okay. Fourth mod, if you go to your this module, arithmetic module, one question will be from multiplication, one question will be from divisor. Okay. Multiplication also I don't know whether it is both multiplication algorithm, bit per recoding, I don't know. Anyone they will ask. And even in division also, one question will be 100%, but I don't know whether it is restoring division or non-restoring division. Okay, so then we will take one more small example. That means only 3 bits will take. Okay, we'll divide by hope I'll take 4 by what we will take. Shall I take 6 by 3? 6 by 3. Okay, I'll divide 6 by 3. We'll take small number and we'll do it. So still those you have not understood, you can understand by that time. Okay. So we'll take very simple problem and you can do it by yourself easily. Okay. So I'll take that. So I'll keep this. Yeah, I'll take. Okay. So now I'll take simple number 8 by sorry not 8, 6 by 3. 6 by 3. That's what my number. I have to divide 6 by 3. Okay, I'll take very simple number. Okay. 6 is nothing but 110. So if it is 110 means your divisor. See, I'm writing here Q. Q I'm writing here. Q is nothing but 110. If this is 110, what's your A? How many bits of A? First. Very good. 1, 2, 3, 4 bits. Why 4 bits? Number of dividend bits plus 1. Okay. So, and what is your divisor? 3. 3 is nothing but 1, 1. Okay. Oh, please even write. Even write. So, this I'll write 0, 0. 0, 0, 1, 1. So, please write it. So, now how many cycles will come? Can you tell me? ಎಷ್ಟು cycle ಬರುತ್ತಪ್ಪ? How many cycles are required? Exactly, only 3 cycles I'll get. Okay, now. So now I'll go with my division. What I will do, this is my m. In one side you write even minus 3 because I want to subtract means even I want minus 3, isn't it? So somewhere you keep it while I require, I'll ask you people. Okay. So we'll do the first procedure. Okay, this is what my initial procedure. Initially, this is not initially. Initially, I'm going to declare. That's all. Okay. Next step is shift. Shift. Okay, shift towards left side. So this will be on shifting towards left side. This space will be empty. So this position will be empty. So this 0 will be shifted towards left side. This 0, 1. This 1 comes here, 1. And anyway, A is having 0, 0, 0, 0. So all data are 0, 0, 0. Okay, now what is my next thing? Subtract. So as I told you, I required subtraction means 3 I am going to subtract. 3 I am going to subtract means 3 become minus 3. So what's the 2's complement of 3? 0, 0, 1, 1. 1, 1, 0, 0 plus 1. So 1, 1, 0, 1. 1, 1, 0, 1. Is this correct? Correct? Yes? Yes. Okay, now? Now I'll just add it. 1 plus 1 is 0. Carry 1. See, everyone should do this. Every student should do this. Please, everyone should do the problem. Okay? I want you to do simultaneously with me. Okay, now? So that you are able to understand the problem. And it is important, 100% guaranteed question. If you have any doubts with my words, can check your previous year question papers. Okay? 1 plus 1 is 0, carry 1. So 0 plus 1 is 1. So 0 plus 1 is 1. Okay. So this is what my value. So now what I should do? I have to do the Q naught. So set Q naught. Can you tell me what is Q naught? Yeah, Q naught will be 0. So since this bit, the last bit of your register A, the leftmost, okay, the leftmost bit is 1 here. So your Q naught will be filled by 1, 0, 1, 0. This empty space. Now I'm going to fill by 1, 0. Okay, this is 0. After this, since this is 1, I want to, what's my next thing? Can you tell me? Can you tell me somebody? Very good. We have to restore the value of our register M, that is 3. Restore it. Restore it. I'll write here the same thing. Restore. You have to write this actually. See, in exam, ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಸುಮ್ಮನೆ shift value you are going to do and you are going to do operation. No, it doesn't work out. You have to write that shifting, subtract, set Q naught, restore. You have to write it every information and cycle information. Okay, please note down. You have to write everything. ನೀವೇನ್ ಮಾಡ್ತೀರಾ left side this is there, no, initially shift to subtract, you are not going to write anything. Don't do that. That's actually required. Okay, so next 0 plus, even in the scheme of valuation, no, they will give to the faculties. Okay, so even in that also they'll mention everything. Okay, now I'm going to restore it. That means 0 plus 1 is 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1. So that carry 1 is additional overflow data, just neglect it. Okay, so we have data something like this. Till here you have completed your cycle 1, first cycle. See, if I'm wrong anywhere, please tell me. Okay, if you feel ma'am you're wrong somewhere here, means please inform me now only. Okay, Otherwise, I will get wrong answer. That's the problem. So please don't see to don't see like everything I'm writing is correct. Okay. If I'm wrong with some addition or subtraction, please inform me. I'll correct it. Okay. Next step. Next step is shift again. Shift. Okay. This bit will be shifted towards left side. 0, 0, 1, 1, 0, 0. Okay. After shifting, next is subtract. Hope everyone is doing along with me. Subtract. So subtract is subtract your m. M means what? 2. So what is 2? Negate it to minus 2. Minus 2 means I already written 1, 1, 0, 1. That's why I told you. Please write it somewhere in your book. Okay, minus 2. Okay, 1 plus 1 is 0. Carry 1. 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 Carry 1 means additional bit. Just neglect it. Okay. So I'll be having here 0, 0 with empty space. Isn't it? In the Q. Now tell me, what's my Q naught? Set Q naught. Exactly. Yeah, it's 1. Q naught. Set Q naught. So this will be 1. Here, I have set Q naught 1. Now my question to you, shall I restore or not? Shall I restore my divisor or not? Yeah. It's not required. Exactly. Not required. Okay. Since this bit is 0, no need to restore it. Just write the Q naught. That's all. Okay. So this completes my cycle. Which cycle? Second cycle. Okay. So after your second cycle completes, again same procedure. Shift. Shift towards left side. 1, 0, 0, 0, 0, 0. Anyway, all bits are 0. So 0 I've written. Okay. So this is I've shifted towards left side by 1 bit. Next is subtract. So normal procedure, subtract. So I'm subtracting 1, 1, 0, 1. That means your divisor you are going to subtract, it is minus 2, sorry, minus 3 it is, right? So I'm adding now 1, 0, 1, 1. Okay. So you are getting the, now you have to set Q naught. Q naught elder value. Q naught value will be 0. Why that is 0? Because since this bit, the last bit will be 1. Okay. That is why I'm going to set my Q naught value as 0. Okay, 0 I'm filling here. Okay, if you want, you can write it here. I've restored. Sorry, I have written set Q naught. Next thing is I have to restore. I have to restore. Since this bit is 1, I have to restore and I have to set Q naught both simultaneously. So on restoring your value, means you are going to add the value, isn't it? So 1 plus 1 is 0, carry 1. 1 plus, see, 1 plus 1 is 0, carry 1. So with this carry, 1 plus 1 is 0. Carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. Okay, this carry 1 is, it's an overflow bit. Okay, more than 4th position. If I get a bit, means that's an overflow bit, just neglect this. Okay, just neglect this. Okay, so now you are going to get a 0, 1, 0. So you have restored. So by this, what I've done, I've completed my third cycle. Okay. So actually there are only 3 bits are there. So only 3 cycles. It will take only 3 cycles. You have to stop it. Okay. Don't go to further, procedures. Okay. Just stop it here. Okay. Now you note down the value. What value? Go to your register A. So this is your A. Isn't it? What's your A value? Your A value will be reminder. What's the reminder? Can you tell me? What reminder you got now? Exactly. You got the value reminder 0. Yes. And quotient. What's your quotient you got? Quotient will be, it is 2. It is 2. 0, 1, 0 is 2. So that is nothing but you are going to divide your 6 by 3. That is nothing but sorry, 3 by, you're going to divide your 6 using 3. That is nothing but 3 2s are 6. Okay, so 0. So 0 is remainder, correct. Quotient is 2, correct. Okay, now clear? Please, everyone, is snap the way. Just take this problem as a snap and keep with you. Those who have written, those who have written completely fine. Even you can take snap along. Screenshot you can take, right? ತೊಗೊಳಕ್ಕಾಗತ್ತಲ್ಲ ಸ್ಕ್ರೀನ್ಶಾಟ್ ತೊಗೊಬೋದಲ್ಲನ್ರಿ yeah even I can take yes take the screen sorry okay so like this you available means take the screenshot you can keep with you isn't it now my question to you everybody understood yes think totally we have done 3 problems yes sir everyone everyone done yeah yes okay actually 90 students are there actually third now for my class yes or no understood or not okay okay see whatever we have done this is actually restoring right this is restoring we have another problem we have another problem another method to do the division that is non restoring just see here this is non restoring okay so what is our non restoring is you are not supposed to restore no need to restore you're going to restore no again and again your divisor value you're adding no so I think this one right you're restoring here right so if I want I'll change the color see this is there no you're restoring right see this is restoring here restoring right so this restoring of your divisor is not required that means addition of your value divisor value again and again is not required okay so that method is it's even more simple than this okay so we have to do the avoid the restoring okay after unsuccessful subtraction so I'll tell you what is that unsuccessful subtraction okay so here is the value okay if sign of a bit is 0 shift by 1 bit position and subtract n from a same thing okay but one change is here one small change is here okay so based on your a value see here if your a value is 0 what you are doing in your previous example you are restoring your q naught value as 1 that's all right but here it's quite different you have to restore by 1 yes that is one thing and also you have to subtracts here subtract m from a if this a bit is 1 means you have to add not subtract there everything you are going to subtract right each and every time see in this one you have to subtract each and every time right so here is quite ulta okay you are no need to subtract only if you have this bit is 1 then you have to subtract otherwise you have to add okay so I'll tell you how to do that okay so let me go to the problem directly we'll do the problem okay so I'll show you how to do that so this is the example given non restoring division it's very simple see same example only we have taken which example divide 8 by 3 okay so same thing so I've written a 0000 same apply ಏನು change ಇಲ್ಲ very simple problem no changes no much changes a small changes here in non restoring okay that's what I'm telling to you okay this is your a this is your q same data okay a is your registered data 0 and your no, divisor dividend will be 8 so I've written here 1000 okay so then m is your divisor that is 3 00011 that's also same Then first procedure also, shifting procedure is also same. Okay, shift it towards left side. So 0, 0, same procedure, okay? No difference here. 1, next this 0, right? This 0 will be here, 0, 0, 0, everything is okay. Okay, hope you are clear. So after this, what you should do is very, very important. Okay, so just have a look at this particular problem. See, first initially you have to do the subtract, no need to worry. Normally first thing is you have to subtract. So on subtract, what you'll get? 1, 1, 1, 0, 1, right? So subtraction of your divisor, that means 3 will become minus 3. So minus 3 is 1, 1, 1, 0, 1. Subtract it. What value you will get? So on subtraction, you are getting here 1 plus 1 is 0, carry 1. So 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 1 is 1. Now come to the important point here. Here is a change. Set Q naught. Whenever you have Q naught is equal to, whenever you have this last bit is 1, what's your Q naught value? Q naught value will be 1, right? This is 1 means your Q naught will be 0. Are you agree? If this bit is 1, then your Q naught value will be what? 0. I have to put it as 0. Yes, I'll put it as 0 here. See here? 0. That's fine. Are you clear? 0. That's fine. Nothing to worry. Okay, same thing. Now don't restore. Understood this step? Don't restore. Previously, what you are doing, as soon as you see this number 1, you are going to set the Q naught value as 0 and you're restoring your divisor, right? Please don't restore. Okay, go to next step. Go to next step. Are you clear? Everybody understood? Go to next step. But in next step, what you should do, don't do subtraction, do the addition. Previously, what you are doing, after shifting, you are doing subtraction. No, don't do subtraction, add it. Okay, so I'll take this value now, shift it. So 0, 0, 0. So this is on shifting, this will come like this. This is the value we'll get after shifting. Then add value. Okay, since this value is 1 means just add it in the next step. Don't subtract it. Okay, 0, 0, 0. Add means what? Node minus 2, not minus 3. Keep the same value as positive 3, just add it. Okay, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1. Okay, so now again, so this is 1. Since this bit is 1, what you should do in the next step, you have to add, don't subtract. That's the thing. Okay, in next step, after shifting, just add the value of divisor. Okay, shift it. I'll shift the shift. Next step is shift, then add, not subtract. When you have to subtract, if this value, if the the leftmost value of your register A is 0, then only you have to subtract in the next step. Okay, so next is again shift it, then add it, then Q naught you have to set. Okay, how to set Q naught? See, since this last bit is 0, you have to set your Q naught as 1, 1, and after that, in next step, you have to do the subtraction. Okay, subtraction means what? So take your, after shifting, please don't do subtract there only. Shift it, then go to the, in next cycle, subtract it. Okay, subtract 3 means what? Minus 3. So minus 3 means 1, 1, 1, 0, 1. Okay, 0, 1. Then you write the value. 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 1, 1. Okay, hope you are clear. Then here, see, since Q naught is, since Q, I'm going to see the value of this last bit, the leastmost, the leftmost bit is 1. So I'll set my Q naught to 0. Okay, so this is what. Hope you are clear. So now I got some answer here. See here, 1, 1, 1, 1, 1. Is this answer correct? Is this answer remainder is correct? After the fourth cycle, I will get register A value as 1, 1, 1, 1. Is this wrong answer? Actually, what answer I should get? I should get an answer as 2, right? 8 by 3 is nothing but 2 I should get as reminder. What answer I got here? 1, 1, 1, 1. Wrong. This is wrong or not? Is this wrong answer? Yes? You're getting my words? Yeah, this is wrong answer. What you should do, at last you should do one thing. Now, at whatever the reminder you got, no, for that you have to add your divisor value. So what's your reminder? 11111. Okay. For this, you have to add your divisor. What's your divisor? So divisor is 3. Right, add it. On adding, you will get 1 plus 1 is 0, carry 1. 1 plus 1 is 3. 3 is nothing but 1, 1. It means 1 you keep it here, 1 and take it as carry. So 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. So just neglect this additional bit. Okay. So what answer you get? This is what your exact correct reminder. Okay. So at last you have to restore. Lastly, for register A, you have to restore. Okay. Final, after your cycle completes, later you have to restore the value. Then only you will get the correct reminder value. Okay. So anyway, you have a quotient will be correct. For reminder, I have added my divisor value so that I got the divisor reminder correctly. Everybody understood? Not understood? Yeah, we'll take one problem. We'll take problem. Chikkudu, small problem we'll take. Which one? Same thing. 3 by 6 by 3. Okay, now the same problem I will take. I'll take new problem. Please take a paper and pen with you. Totally start mana. Okay. Discord. Very simple problem it is. So I'll take new slide. Small change, that's all. In there, what you are going to do, you are going to restore everywhere. Here, no need to restore. But there, you are going to subtract everywhere. But here, no need to subtract everywhere. Okay. So based on the leftmost bit, you have to subtract and add. Okay. So I'll take this now. So I'll take my new slide. So let me take, what's the value I'll take? Yeah, I'll take 6 by 3. Using what method? It is non-restoring. Remember, okay? No restoring here, okay? That is why. So I'll take my value, divisor will be, dividend I'll take 1, 1, 0. So what's your A value? A will be 0, 0, 0, 0. So I'm going to initialize. What's your value of 3? Divisor, that is M, 1, 1. I've initiated. After you have initiated, what's your first step? Shift. Okay, shift towards left side. Okay, that is nothing but, see, you have to shift this A and Q. Don't do anything with your M. Okay, so shifting towards left side. 0, 1, 1. So anyway, A is having completely 0. So 0, 0, 0. So first step, you have to do it always subtract. Subtract. Subtract your 3. Your 3 is what? 0, 0, 1, 1. On subtraction, what you will get? 1, 1, 0, 0 plus 1 is 1, 1, 0, 1. Minus 3. So just subtract it in the first step. 1, 1, 0, 1. So I'm getting the value here. Just 1 plus 1 is 0. Carry 1, 1, 1. Now tell me, what is your Q naught? Q naught is what? Is 0. Yeah, very good. So Q naught, I'm going to set it as 0. See, I've set the Q naught. Very good. And now you should tell me, in the next step, shall I subtract or add? Very good. Yeah, we have to add. Don't take subtract. Simple method. Very simple method. Yeah, I think everyone is understood now. Exactly right. So what you should do in the next step, you have to add. Don't subtract. Okay. So in the next step, that means next cycle. Don't now only please don't subtract. Don't add. Okay. Please don't do that. Huh? This is your first cycle. In first cycle, I've completed. Then go to shift. Shift is my first step. Okay, same thing. Shift it. On shifting, what I'll get? 0, 0, 1, 0, 1, 1. If I'm wrong, you just tell me, okay? In case if there is any mistake. Shift. Next is what? Addition or subtraction? Huh? Addition, because this bit is 1 means you have to do the addition in the next step. Don't subtract. That you should remember. Anyway, you have to remember. Add means what? Just add your divisor. What's your divisor? 1, 1. Just add it. 1 plus 1 is 0. Carry 1. 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 Okay. Now I'm here. Now give me what is your Q naught. Set Q naught now. Yes, Q naught will be 1. Very good. I have to set the Q naught by 1. Very simple. Now please tell me, in the next cycle, shall I subtract, shall I add? Superb. We have to subtract. ಏನ್ರಿ ಆದಿತ್ಯ ಇಬ್ರ ಸ್ವಲ್ಪ ಜನನೇ ರಿಪ್ಲೈ ಮಾಡ್ತಿರಲ್ಲ, ಎಲ್ಲರೂ ರಿಪ್ಲೈ ಮಾಡಬೇಕು. Okay, so next step, I'll go to cycle, next cycle. What's the cycle? So this completes my second cycle. I'll go to third cycle. In the third cycle, you already understood that I have to do the subtraction. Okay, let me take shift operation first. Shift towards left side. So 1, 0. Okay, anything here everything is 0, 0, 0. So I'll take it as 0. Next, subtract. See how to subtract here. Okay, because in the previous step, I got my value of the leftmost bit will be 0. That is why. Subtract. Subtract 3 means what? Subtract 3 means I already done here. Minus 3, that means 1, 1, 0, 1. So just do the subtraction. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 is 1. Okay. So now tell me Q naught value. What's my Q naught? So my Q naught value will be based on this. So this is 1 here. Anyway, if this is 1, my Q naught will be 0. Actually, if I'll go to next cycle, what I should do? I should add or subtract. If there is next cycle, means whether I should add or subtract. We have to add, but I'm not going to next cycle. Why? Because this is my only 3 bits are there in the dividend, so I have to wind up now. That means third cycle. Here only it will complete. 3 times you have to do the operation because only 3 bits are there in the dividend, isn't it? That is why. Okay, now so I got some answer here. So in the register A 1101, this is wrong, right? This is wrong answer. What I should get actually, it's 0000. I should get 0 as a reminder. I got some wrong answer. What I should do now? What I should do now? For this existing reminder value, which is the wrong answer, what I should do? Restore. Restore. Yeah, that means you have to add your divisor value. What's your divisor? Divisor is 3. That means 1, 1. Okay. Just add it. Just add it. Yeah, add m. Correct. Or it correct. Add m. That means 1 plus 1 is 0. Carry 1. 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 So this is overflow bit. Just neglect this. So bits is 0, 0, 0, 0. Okay. What's your reminder now? Reminder is equal to 0, 0, 0, 0. Quotient will be same. Okay, nothing to worry. Your quotient will be same value in the Q register. That is 0, 1, 0. That means 2. This is your quotient. This is your reminder. Reminder, be careful. You have to restore the value of m or divisor value. Okay. Hope here everybody cleared the understood. You take some examples. You take one problem I'll give to you. Okay, 9 by 5. Please do this problem 9 by 5 using the both restoring and normal restoring. Next class I'll ask you. Okay, 9 by 5. To divide 9 by 5. Use both methods, restoring and non-restoring. Okay. Okay, I'll take the attendance now. Any doubts you have, please? And you take this snap, okay? Take a screenshot of this. Tell me the answer. Asta? Asta?
Yes, ma'am.
Okay. Yusuf?
Present, ma'am.
Okay. Okay, just a second.
ಈಗ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ ಅಂತೆ ನಾ ತಿನ್ಕೊಂಡ್ಬಿಟ್ಟೆಲ್ಲ ರೆಡಿ ಅಲ್ಲ
I'm USN 5 present.
Hey, Irapa, let me wait for a while.
ಬರ್ಲಿಲ್ಲ ಬನ್ನಿ
Wait for a while, just a second.